Okay, welcome everyone. We're here today to discuss details of the Orleans networking layer, networking, messaging. There are some ideas entertained on the Gitter issues if we should try to outsource some of the functionality to maybe some library and whatnot. And it's good to dive deep into what's there today to kind of understand what we can do to improve it. So Jason's gonna present a long presentation of probably like 2 slides, hopefully for 10-15 minutes, and then we can discuss, answer questions, and have open-ended discussion. So I'm handing it off to Jason now. Jason, you're on.
Great. Yeah, this is an extremely long presentation with 4 slides, including the intro page. So yeah, we're going to be in trouble on this. So let's just jump into it. This is a very high level breakdown of the architecture of Orleans streaming. The next 2 slides will cover specifically how we handle the send call path, what we do when we send data, and the next slide is more details on how we receive data, because those 2 paths are completely different stacks. Well, not stacks, but completely different pipes. So I want to cover the overall high-level architecture here in this first slide, so we can kind of get a big picture of things. While we're focusing mainly on the networking layer, I wanted to give it in context of Orleans, so I kind of wanted to start with looking at grains, or start from the grain calls on down. When a grain call is made, it ultimately turns into a message that needs to be delivered over the network. So we have a message and a destination. How the grain call gets turned into a message and a destination, I'm kind of just referring to as magic right now, because it's not really related to the networking layer. But once it is a message, it's given to the message center, which looks at that message and decides whether it's a remote message or it's for its own silo. If it's for its own silo, if the destination is itself, then it will just hand it directly back to the incoming messages to be dispatched to the grains on this silo. If it is for another silo, it will go to the outgoing messages. The outgoing messages is where it actually starts going into the networking layer. What we have is a set of senders that deal with sending all the outgoing messages. The number of senders is a configurable setting on the silo. The default is 1 per processor, but it's configurable. Each of these senders has a message queue of all the messages that are outgoing for that it is responsible for sending. And it has a worker thread that reads from that queue and sends those messages out. Sorry, go ahead.
This is Gabby.
Hi, Gabby.
Hey, Gabby, I was just emailing you. Yep. So Jason started going over.
I had to install it in a different place or whatever.
Yeah. No worries. So all Jason covered so far, you know pretty well. So you didn't miss anything.
Yeah, I pretty much just got started. Right now I'm just covering the very high level architecture of how Orleans uses networking and how its networking is laid out. The next 2 slides will go into more details on the send and the receive.
I can see the slides. I cannot see the slide.
Oh, so you're just on the phone?
Well, I'm trying to have this in my phone, this Skype link. I don't know why it doesn't show the slides. Maybe I should do something.
No, and then
I don't know.
Just show up.
I see the slides or something.
Well, I don't think slides are critical for you. So let's let Jason continue, and then we can chat privately, and I can help you set up.
Okay.
Okay, Jason, keep going.
Okay. Gabby, you're familiar with the senders and how the senders work, but that's kind of where I was discussing when you came in. So each of the senders has its own queue. For outgoing messages, it's responsible for sending, and it has its own worker thread that reads from that queue, serializes the messages, and then sends them out to the target silo. On the receive side of things, when we receive messages, when a silo receives messages, as most services, it has a listener or acceptor socket that it receives incoming sockets. And once it sets up those incoming those sockets from other silos, we set up asynchronous reads through asynchronous I/O. So it's unlike the senders where we have a specific thread writing to each writing messages. On the receive side, we just rely on asynchronous I/O to process the incoming messages, or at least dispatch them. Does this by reading a rather large. We give a rather large buffer to the read operation and let it read in as much data as it can within reason, and then we go through that buffer, parsing out messages that have been read into that buffer and then sending them off to be dispatched. If the message buffer turns out to be too small for large message, if somebody sends like a 3 meg message or something, we will grow the buffer until it's big enough, and then we will read that larger message. Does anyone have any questions about the high-level architecture of how Orleans handles, or the Orleans networking works? Crickets?
So,
okay. Go ahead.
If there's no question, I had I didn't see the slides, maybe you already described it this way, but I had a more gradual way to explain it. So if you want, I can show you a little bit different view on this, from simpler to more complicated, gradually.
Well, not sure if. Well, yeah.
Okay.
Yeah, we haven't talked about this, so I don't really know what simple to gradually means in the context of this, because I was just trying to cover the high level architecture. Now I'll drill down into the send and read. No, that's fine. That's fine. So next thing we're going to kind of dig a little bit deeper into.
Hold on, Jason.
I
wonder if anybody else. So Gabby jumped first.
Sorry. Yeah.
I wonder if people that are hearing about this for the first time, if the whole picture makes sense, or if something confuses, like black magic, or.
Either I was clear, or everyone's completely confused and doesn't want to say so. So I'm gonna go to the next slide and see if we can.
Maybe I know.
Oh, we have 2 Gabbies on the line. Talking to each other, I guess.
Yeah, I muted one. Sorry, Gabby. Maybe I muted the wrong one. Oh, he's gone anyway.
Anybody else? Miji, Josh, Gutenberg, Richard? Should we keep going?
Yeah, go ahead. Yeah, go ahead.
Okay, go ahead, Jason.
Okay. So next thing we're going to go a little bit deeper into is the outgoing pipe.
Can I maybe start a little bit behind, take us a little bit step back, okay? Can I?
Okay.
So there is really 2 layers, logically. It's not necessarily the code is 100% written this way, but logically there's 2 layers. There's a networking layer and there is a messaging layer. Okay? What is the difference? Networking is only about sockets, open socket, closed socket for given IP. So you give it it knows to open sockets for IPs. It knows to push bytes into socket and receive bytes from sockets. So it can push just by synchronous send, or maybe in the future we can do asynchronous send. There are different APIs how you can work with sockets, right? Using async arc, using not async arc, and the receive also you receive synchronously, asynchronous. There's multiple ways. But this is what I call networking, the pure socket layer. Messaging is a layer above that, okay, which basically deals with messages. You send message to silo. So it's not like sort of now about IPs. It's about silos or client connecting to gateway. And it has a message. And then it has threads and queues and deserialization of messages. Okay, so it's sort of like an RPC layer if you want. So it adds threads, queues, translation from like silos to the right socket, etc. Right? Is that so? Like that's how it should be. Like now in the code, it's not necessarily separated this way, but it should be this way. And a lot of times it is. So when we are discussing like what to change, right, and what we want to be injectable, like both options are there, right? You not necessarily need to change the whole messaging stack, the whole RPC stack with queues and threads. You can only change the networking layer, or maybe you want to change both. And we don't like. I don't know if we want necessarily to go into all the details of how those things are done.
Okay, so hold on a second, Gabriel. So you are saying that if we are willing, for example, to decide, hey, let's use libuvi to be the networking layer, we just have to change it, and the RPC, the messaging layer, will stay the same, right?
Sorry, you have to repeat it. I did not understand. If you want to change what?
If you want to change the networking layer, for example, to use libuv, like ASP.NET servers, and we do not need to change the messaging layer, just a matter to replace the networking, the sockets itself. Is that correct?
At high level, yes. I mean, I don't know exactly what libuv and how this is in-place replacement for like our networking layer, but yes. Let's say you want to use different sockets, right?
Yeah, it's basically a socket API, asynchronous socket API.
Yeah, exactly. Right?
I would put it even simpler. So at the networking layer, you're dealing with addresses, whether it's IP addresses or something else, and sending bytes. At the messaging layer, you're sending messages where you have logical address like silo address or client, and you have some structure, you have headers, you have bodies. So you're sending some structured data as opposed to the networking layer, you're pushing a series of bytes to a particular address.
That's exactly that. So it's about address, like addressing, different addressing and different data, but it's also very important. There is messaging layer at this thread, like these queues and threads, right?
Yeah, so they are reading and pushing data to the socket, in the line socket layer.
I mean, yeah, there's most networking layers have, whether they're just the I/O layer or they include other things, they usually have a series of layers. There's low-level I/O, like sockets. How do you get the data in and out? There's usually some buffering built on top of that, which is mostly for performance. Then serialization, reading data out of the buffers and turning them into interesting objects that are actually usable. And then there's taking those objects, either processing or dispatching them to what actually needs that object. Then there's also the addressing of figuring out when you go to send something where it goes and where it should end up. So yeah, there's a number of layers, and this presentation isn't really broken up into like those layers and what those layers do in our system, kind of because that a lot of that, as Gabby kind of alluded to, a lot of that code is kind of glued together. So what I decided to do is kind of talk about what it actually does, like the behavior of how it works. And afterwards we can talk about how to break this apart and maybe what pieces can be replaced, or how it can be layered better so that components can be broken apart. But right now, it's not really modularly organized in those layers. Our existing networking layer isn't anyway. So
I would say it's not perfect, but I wouldn't say it's like completely messy. Not. I mean, it's not like a one very clear like two APIs that are cut across. They enable like 5 different objects, but there is a socket manager and there is like a specific sender. But
yeah, there's a buffer pool and there's a serializer. Yeah. I mean, all the pieces are there. They're just not necessarily. They're not necessarily broke apart in layers. They're intimately intertwined right now.
Yes, they are pretty important. Yes. So that's one sort of step back that I wanted to give. Second step back is there are 6 places to consider. Ideally there would be 2, but in fact this is 6. So what are the 6 different places? So there is a place that silo sends messages to another silo. There is a place that silo receives messages from another silo. There is a place where silo sends messages to client, and silo receives messages for client. And there's a place where client sends messages to silo and client receives. So in general, there are 6 different components, right? Ideally, there would be 2, sender and receiver. And if some of them need to sort of override something, it is like very cleanly, like, extends and like specializes, but there would be really like only 2. So in fact, in reality, it's not 6 and not 2, it's somewhere in between. It's like I looked at it yesterday again, it's sort of like 4.5, 4 or something like that. Very far in the past we had 6, then we sort of started improving and we improved some. So it cannot really be 2, even like in a perfect world, because there are actually different things that you need to do sometimes. But they could be layered, so there's like 0 code duplication. So now it's not exactly like that. It's sort of like 4, 4.5.
Okay, well, I mean,
it's also something just to consider, right? It could improve there, okay? I don't think we can get 2, but it could be less.
So maybe before we jump into discussing improvement, let Jason cover the other 2 slides.
The kind of goal of this is to try and get a reasonable amount of information out there so people understand the flow of what these layers do right now, and then we can talk about breaking them apart and how we can either modularize them or replace pieces. Okay. So unless there are more comments, I'm going to go on to the outgoing path. Actually, I have one more comment going back to this, kind of related to what Gabby was saying, and why these 2 paths are different, why the outgoing path and the incoming path are different. From the description here, when we're sending data, we open the socket and we send the data. On the receiving side, we accept a socket and we receive sockets. These are different sockets. Each socket is pretty much, for the way we use it, is one way to socket, which is a little different than the way a lot of other networking layers work, where they read and write from the same socket. They have a dedicated socket between 2 things. Every silo pair will have basically 2 sockets, send sockets, one-way send sockets between the 2 of them. Just to put the information of why these things are kind of separated out like this, and why we can separate the paths. So for the outgoing path, which would be sending on a socket, as I mentioned before, starting with a grain call, we create a message from that. We take that grain call, turn it into a message. That's kind of internal Orleans magic of that. We address the message, figure out what target silo it should be going to. We select a sender to send that message over, and that sender is selected by doing basically a modulus of the hash of the target silo based off the number of senders you have available. This means that for a specific silo that you're sending to, you will always use the same sender to send to that silo. A sender will send to multiple silos, but no silo will be sent to by multiple senders. This is in part how we handle some of our ordering, is that everything going to a silo will go into to a specific silo will go into the same queue and be sent in order. As I mentioned before, we initially put these things into the sender's queue, and then the sender thread does a blocking read on that message queue to get at a message. Blocking reads here because we don't want to be spinning or using any extra CP. If there's no message to send, there's nothing for that thread to do, so it just blocks. Once it gets a message from the queue, the sender thread tries to obtain a socket to that connection. If one doesn't exist, tries to obtain a socket to that silo that it's trying to send to. If one doesn't exist, it'll establish the connection. If the connection is lost, it'll reestablish. After it has a socket to the sender, or to the silo, the target silo, it will serialize the data in the message. And the messages in our networking right now have basically two components. They have a set of headers, which is metadata about the message, and a body, which mainly consists of the arguments from the grain call and the method information. Both the header and the body are variable size. So we add we precede these two chunks of data with a sizes structure, which is a fixed size that we know how to read, and that tells us the size of the header and the body once serialized. So we serialize the headers, we serialize the body, we write a sizes structure that has the sizes of those two once we know them, and we write all these onto the network as a series of buffers with the sizes and then the header and then the bodies. Once we've sent this message over the wire to the silo, to the target silo, the buffers that we used are then returned to the buffer pool, and buffers are reused. The thread then goes back to the queue, reads more data, reads the next message, and does the same thing over and over again. There any questions about this? Okay, I'm going to go on to how we read from sockets, or read input from other silos. We have a listener socket, basically an acceptor that listens for new connections. When the connections come in, we have some minimal handshake logic, and we set them up to start receiving data. We initially set up a 128K buffer that is built from buffers from the buffer pool to read from. 128K was just happened to be the size that we were using during the prototyping. And it worked well, so we never changed it. We considered making that configurable or playing with other sizes for performance, but that has worked pretty well so far. Most of Orleans messages, at least in our testing, tend to be rather small. We read from that. We read everything on the network up to 128K, or up to that buffer size, in a single read, and then we go through whatever we've read, and we look to see if that sizes structure have we read enough to at least get the sizes of the message from it. So we parse out the size of the message and then check to see if the buffer is big enough to read that entire message. If it's not, we grow the buffer. We check to see if we've read the entire message, and if we have, we know the size of the header and we know the size of the body. So we basically construct two segments into that buffer that point to those two sets of serialized data, and then we construct a message with those two segments. Then we take that message and we dispatch it, or give it to the incoming messages queue to be dispatched. We then take the buffers that were in that message, we return them to the pool, and we add new buffers to the end of the pool to keep to the end of the receiver buffer to make sure that the receive buffer stays a size that is useful, a minimum of 128K. The sustainable size that we now have is up to 1 meg. That is, if you start reading large messages up to a meg, we will grow the buffer up to be big enough to read those entire messages. But if they go over a meg, we don't grow the buffer. We don't maintain a buffer of that size. We will continue to shrink the buffer down. Depending on networking needs. There are other things we can do with this optimizations, but we haven't really had the need. Once the buffer has been adjusted, we then go read the next message in the buffer, and we continue doing this until we don't have any more messages in that buffer. Then we take the newly assembled, mostly empty buffer, give it back to the networking layer, and read the next set of messages. If there's extra data that remained in that buffer, we will start reading from the end of that buffer, and so we can continue parsing from that remaining data rather than losing it because it's part of a message that needs to be processed.
Jason, when you say parsing, you don't mean it literally, right? We just read bytes, right? We don't interpret the data other than we read X number of bytes.
So,
correct.
Parse loosely, yes. At this stage, we don't. At this point, the only data we actually read out of the buffer is that sizes. We look at the data in that sizes. We, for lack of a better word, deserialize that, but it's more like parsing, where we look at the bytes and we convert them into sizes that we need, and that's in that step one. And then when we get to the two segments into the buffer that we hand to as the header segments and the body segments, when we construct the message with those, the message will run the deserialization logic on the headers immediately, and depending on if it's a gateway or if it's a silo that's doing this reading, it will either make a copy of the body segments for lazy deserialization later, or it will deserialize the body immediately, like it does with the headers. But it does that when it constructs the body, the message. This is the part where we kind of take data from buffers and then construct useful objects. The message ultimately needs to be a useful object. It's just in some cases we're going to forward it, so we don't want to go through the work of deserializing the entire message when we're just going to write it back onto the wire. If it's a case where we don't think we're going to forward it, we will deserialize the message so it's a useful object when we dispatch it to the grains. Any other questions about this? About how we receive data? Okay, that's about it. Do you want me to leave this presentation up while we discuss things, or do? Yeah, I'll just go ahead and do that.
Yeah, just keep it.
I guess we'll open the floor for discussion now.
This shortage of questions may mean everything is 100% crystal clear, or it may mean, Jason, you confuse us so much that we don't know what to ask.
Yeah, it's usually like a good sign or a bad sign. Either I've confused everyone utterly, or or what I've stated was clear. In regards to replacing the networking layer, there's a number of different approaches we can take, and we've discussed a lot of them. What I wanted to get across in this presentation was just some information about what the networking layer actually does, and to some degree why it does what it does. The different networking layers are optimized for different things. I didn't write this networking layer. I don't know the goals behind why it was written the way it was. However, after playing with it for a while and trying to optimize it and seeing what it does, my suspicion is that the goal of this, a design constraint of this, is that it should be very efficient CPU-wise. That is, Orleans ultimately is kind of an RPC system. It makes grain calls or remote procedure calls to other silos. The goal is for work to be done. The goal is not for necessarily the fastest throughput or the quickest response time. It's to make work possible. So making the networking layer light and efficient seems to be one of the design goals of it. So it is not doesn't have the fastest response time of like any networking library. It doesn't have the greatest throughput of any networking library, but it is very efficient at what it does. And I think that was probably one of the design constraints or goals anyway.
Yeah, it's definitely correct what you said, and I would add, in addition, the design requirement was that it will be scalable in terms of scale to large number of silos and clients. What that means, for example, you don't have like a thread per silo on a silo, right? Like if there's 1,000 silos in a cluster, I don't want like receive thread or sender thread on every silo for every other silo. That would not be scalable. So basically, a lot of those messaging tasks and queues are like partitioning, but demultiplexing a lot of silos on a small number of threads. Of course, you still need a socket, that's right, you need 1,000 sockets, but you only need like a small number of threads. So the scalability was another requirement.
Yeah, I think Abby makes a great point, because the whole design of Orleans, one of the goals was not necessarily to get the highest possible performance, but for sure make it scalable. Because if you are 10% less performance than the ideal, but you scale well, it's much better than your 10% more performance, and you cannot scale out. That's something to keep in mind as we consider options for networking layer.
Yeah, the scalability I think is definitely an important aspect of this design, but and also in the way we've been trying to optimize it, it turns out that there are very different performance characteristics of a silo if you are doing of a networking layer. If you're talking, say, between two machines, two services, or you're distributing across, say, 100, and we ran into a lot of that in the networking. My first attempt at the networking optimization was to add more buffering into the networking layer, making less actual networking calls, and that had really good performance gains when you're testing it locally with like just a couple machines. When it has less benefit when you have 100 machines, because your ability to buffer things and handle things in bulk goes down the more machines you have. That's because your load is distributed across 100 different sockets. You're not going to be able to buffer as much per socket. It was a performance gain, so we left it in there, but it was far more significant if you were doing, say, a deployment with 2 silos versus a deployment with 100 silos. Oh, I just realized people are talking in chat and I haven't been reading it. I apologize.
Yeah, I think there was a question about the current XPlat, cross-platform.NET socket implementation, if that's something ready or not. We haven't looked at it. People that have, so Gutenberg seemed like you have an opinion.
What is XPlat?
Yeah, it works. It works. Yeah, if you get the .NET code today and look at mono implementation of the sockets, yes, it works. But it's not really nice when you're running on Linux. Maybe they will change something on .NET Core, maybe not. But you can rely on that because we will have to support the full .NET as well. So.
Yeah, I'm unfamiliar with the XPlat. I haven't looked at that. Our last attempt at updating the actual socketing layer was to use async args, and we found some issues with those libraries, so we could have worked around them, but we kind of blown our budget just trying to get them to work. So we kind of abandoned that. We haven't abandoned it completely. we're considering going back to that, but that's the only investigation we've done so far in replacing the networking layer that I'm aware of, or the socketing layer.
We're gonna look at it like replace. We're gonna look at improving it by using different socket APIs. And we found a bug in .NET Socket library. Jason found a bug in .NET Socket library, and we could have like done more changes, but not to do this, not to use that API. But as Jason said, we dropped it.
Okay, but we are actually reinventing the wheel. I mean, if the target is, for example, to add TLS support for secure sockets, how do you plan to do that with the current implementation? Are you going to implement the encrypt and decrypt by yourself?
I think it's
Well, that's kind of
question.
That's kind of the goal of this meeting, I think, to discuss what's the best approach. Like, I think Jason was mentioning what's currently done and why, but I don't think we are close and we are saying we should not change it because it's the best. That's the whole point. I think it's how we update it and what are the goals to update it. Like TLS is one of them, and cross-platform, of course. Are there anything else? I like Alex's idea of thinking all the communication differently for a silo-to-silo call, where typically it runs in the same VPN, for example, or well, basically you don't need to secure it anymore, but distinguish between the client and the silo if it makes sense. Like if we can have a good enough abstraction, I don't see why this wouldn't be a goal. I think it would be very nice. I don't think we need to use TLS for every inter-silo communication when we don't need it, right?
Yeah, Reuben actually raising a question on that. The TLS could be used to inter-silo communication. For example, if you have two silos on different networks and you want to tie together via the public IP, you can use a mutual TLS to secure that connection from the both sides. So it's not necessarily true that you are only using it on client silo messages.
So
but to be fair, there's also, like, I'm not dismissing that, but I'm just saying that there are typically alternatives. At least in Azure, for example, you can use VPNs to connect those two different deployments, right? Whereas in the silo, that's not sometimes possible. Like the client might live in a different place, and it might not be practical to have a VPN even. Like there might not be as easy workarounds as the silo-to-silo communications.
So let me maybe give a statement. Let's see if we can agree all on that statement, and then see how we can get there. Okay? A proposal. I'm giving a proposal how we can move forward. So let me describe what I think is an ideal world, right? What would be an ideal world, and let's see if that is agreed that everyone agrees that it's an ideal. So we said there are the 6 places, and there are 2 stacks, 2 layers on the stack at least. The networking, like the sockets, and the messaging, and all the threads and okay. And so ideally, you would want on the one hand be able to change each one of those 6 places to like use different of each one of those 2 protocols. Like ideally, you want to support 12 combinations. That allows you any flexibility you want. You want like TLS between clients and silos, but non-TLS between silos, great. You want like this synchronous, asynchronous. You want to use like that messaging here, but another messaging there. Gives you the most flexibility. That's one. Then, if you actually like don't care, right? Like you want actually, for example, stay with the current implementation, then you basically just configure or inject the same implementation to all those 6 places, so you don't have code duplication. So you want the flexibility to put different stacks in each one of those places, but you also want a unified code. If you don't care to specialize, like would that be an ideal? Does anyone agree that that's ideal?
I think yes. I'm not sure if we actually want swappable implementations, but mostly like configure them separately. That's the at least my take. I don't think the ideal is to have a completely swappable implementation.
At least through config, not
I don't know if it's really how config. I said nothing about that. I said like conceptually.
Right. Like I'm not saying it is maybe a nice to have, but I don't think we need to support like in one use .NET and the other one libUV, and like I think even if we can have a single one in theory that works well, but we can tune it, like configure it, this use TLS and this doesn't, I think that's more than good enough.
Yeah, so different one could be through configurations and doesn't have to be like the different code. That's fine. That's also that is just another way to say what I said. I mean,
sure. Yeah. Okay.
But I mean, based on the questions that people are now asking, like Alexei asking about, like, hey, could you use different cases here, and all the like issues I've seen until now, we don't actually know. Like, people would want very different scenarios. It's hard to predict. Like, clearly we have like the leading scenario now, TLS between client and asylum, but there will be more scenarios. You cannot predict. So ideally, you can sort of do anything, right?
I think what maybe makes it confusing because there are different, like, almost orthogonal questions here or approaches. So I think general refactoring make things better structured so that the potential pieces potentially pluggable. That's kind of a no-brainer, and I don't think we're far from that. And then one line of thinking is, or at least one line of suggestion was to try to use some library to outsource messaging to that potentially.
Is it like the whole messaging or only the networking?
Not the message, Sergey.
Sorry, networking. Sorry.
Okay.
But it's not clear. I mean, tomorrow someone will come and say, I want the whole messaging. I want to plug in, a Thrift RPC or like a Google RPC or like, I mean, I can imagine tomorrow someone comes and says, let's do that one. We can decide it's a lower priority, but I'm saying like in an ideal world, was the networking be swappable and the messaging be swappable?
Right, but what I'm trying to say, so one line of suggestion was, oh, should we take a library like .NET and just use it and potentially save on maintaining a bunch of code in the stack, right? The orthogonal line of suggestion was, let's look at the code we have and use better APIs, more performant APIs, Rio and async args and those kind of improvements within sort of the current stack. How to add TLS, switch to stream version of APIs. It seems like those are almost independent lines of suggestions. I mean, it would require a deeper investigation.
I don't think they're independent because let's say you want to try this RIO or whatever. So like now you need to go in very multiple places to change them. So ideally you would change them in one place.
Well, that's where I started. I said refactoring so that things are pluggable. That's sort of a no-brainer that you need anyway, right? So that's before those two things.
So when I like thought about this meeting yesterday, I also sort of drafted to myself like a suggested plan how we can get there. So let me share it with you. It only has like a first step. First, I think like what you, Sergey, said is exactly, it's no-brainer. What we need to do is we need to just clean up the code, unify, remove some redundancies. It's not bad now, but it can be improved. Better layering. Like for example, clients now, right? They pick which gateway to connect. That, in my view, does not belong neither to networking nor to messaging. This I call it routing, client-side routing. Like on the silos, you decide where to route, like based on the directory, like based on the grains and activation. Is a completely different layer. So from the messaging perspective, you just already know I want to go to the top. On the client, that's not the same. You need to pick a gateway, but that code is intermingled with the messaging and networking code. So that needs to be separated out of that. So from this cleanup and refactoring, remove some redundancies. You want to do that, I think, as a first step. It's a no-brainer. Then you want to find those clear places where, like, this is where the networking ends, this is where the messaging starts, this is where the messaging ends. Very clear interaction with, like more clear interaction with buffer pool. And so you want to find those and put a nice abstraction there. That's the second thing. I think you want to do that just to be much easier, like, again, to maintain and swap. And then you go and say, okay, I want to try RIO. Okay, so now you know exactly where to try it, only in the socket layer, and you do that. Okay, you want to try .NET? Okay, so you completely replace the messaging layer in all the 6 places. Like the configuration, in all the 6 places that I mentioned. You will be able to do anything.
Yeah, I'm in agreement. So I just bundled the first 2 pieces that you mentioned as one. Yep, but other than that.
And I think the hard part in that is like when you decide where to put those cutting, like, abstraction layers, right? This is where you need to look at probably more than one implementation. Like, let's say you want to bring some like messaging layer or network layer. You need to decide an abstraction that will be good for different implementations, right? That's hard.
It's really hard.
So from our perspective, there are kind of 3 layers that would be interesting to be able to plug in at without having, without completely replacing large portions of this, and that is the I/O layer. That's basically your low-level socket layer. I think we could do some work to isolate that and make that so that we could plug in different, basically secure sockets or other low-level I/O, secure low-level I/O at that point. There's the buffering and serialization. I don't think anyone's interested in replacing the buffering, but sometimes serialization systems are kind of depend on a specific buffering, so those kind of may come together or may not. But that's basically how you convert the binary data that you're getting over the wire to an interesting object. I can see people wanting to replace that. And then once you have the objects, you deal with dispatching them to the grains, and I think that probably needs to stay Orleans, but there are RPC frameworks that can kind of help us with that. But I think the further up the stack you go, the less value you get from these things. I think the serialization, the I/O is where you'd probably see the most value, is being able to replace those systems. And for something like securing Orleans protocol so that it can be used over the internet with possibly insecure clients, you need to address both those, because the sockets aren't encrypted, right? So there's that. We need to have some secure socket layer for the I/O layer, but then also at the serialization layer, we have our own binary serializer, which was optimized to be fast and write things fairly compact, and it's good for what it is. It's just, there's no problems. It does what it's supposed to do, and it does it rather well. But it's not terribly secure. If you have a malicious client, you can burn up much of someone can burn through your service's memory or cause you great harm to your service by sending poorly formed networking packages that are valid. So they wouldn't necessarily cause serialization errors. They would just eat up all your memory and things like that. So the serialization library itself is not necessarily secure and hardened for unprotected use. So to make something secure, you'd want to cover those. Now, if you have secure clients and all you're worried about is the network between you and your client, your servers are secure and your clients are secure, and you just have the network between, then you can get away with just encrypting the I/O. But if you have insecure clients, then you're going to need to also harden the protocol and the serialization.
Yeah, I agree with what you said. Yeah, first point, I think that probably from priority perspective, it's swapping the I/O networking layer is more important than swapping the whole messaging stack. Although I can see how like in 6 months someone would want to bring the whole RPC as well. Someone will sure want that, but priority-wise, I agree with the networking one. And also what that about like the securing from there. Yeah.
Well, wanting to replace the RPC layer versus actually it being practical and of value, I think those are different things. I mean, I can see somebody looking at an RPC system going, "Hey, wouldn't it be great to just, plug this into Orleans?" But in the stack as it is now, and in the future, Orleans is fundamentally an RPC model.
The way Sergey presented it actually, like he sort of said, "Hey, like, why do we need to support this whole legacy of the whole RPC layer? Maybe we can bring someone else's RPC." So basically, the way you will bring it is each silo expose like just one method, like do, and then this is a full RPC, and then like so we not necessarily have to map like grains to like this lower level RPC, right? It's like one generic sort of server, but it does all the threading and it does the serialization and the buffers, everything. It does both the networking and the messaging, and then you just have a layer on top of it that multiplexes to the grain. So there's a value in that. It's just removing like the code that we need to maintain. And potentially maybe someone has a much better RPC, like more performance. So there is a value. And I agree that priority-wise it's probably less.
Yeah, I think Gabi described my pink unicorn pretty well. It's just one method, and it magically delivers everything efficiently. But I wanted to do a pulse check. I think we got hung up in kind of mostly discussing within the core team, which is kind of, I'm afraid, is an echo chamber. I wonder if people that are not inside the core team, what they think.
There's another thing that we was discussing in Jitter that Richard just mentioned on the chat, which is the ability to connect different kinds of clients, like for example Node.js or Java or non.NET clients. I mean, how can we open the protocol from the gateway to, or at least describe how the protocol works so people can implement Orleans clients somewhere else?
I think it's a great question, and it seems like it's almost unrelated, almost to the rest. Because you obviously cannot use same binary serialization, right? You will not binary serialize from Java unless you're using like primitive types. So, but yeah, we can use, say, JSON or something cross-platform, protobuf. But then you still need to deliver, and this if you're sending byte arrays, so that should plug into this nicely refactored, layered structure easily if you're just sending byte arrays that are compatible. That's my initial reaction, at least.
Yeah, ultimately, when you're talking about like being able to read and write from other clients, you're talking about the wire protocol and we don't. Our wire protocol isn't a formal protocol that it's kind of evolved over time. We don't have it's not something we can say, here's the spec to our protocol, and if you conform to this, you will be happy. It's just not going to work that way. We would, so to get to that point, we'd have to either formalize our protocol, or replace it by replacing our serializer and formalizing our handshakes and our connection sequences. If we did those things, that we had a very formal handshake that could be documented, and people knew what it was. So when you connected, you knew how to tell the silo, you are what you are. And if we had a serialization and as I mentioned before, possibly related buffering, that you could replace that in the silo, then we could easily replace our networking with something else, and then our wire protocol with something else, and then replace it with something that's either formalized already, or the user could replace it with whatever protocol they wanted to use. But yeah, it really comes down to the wire protocol at that point.
Yeah, I'm not even saying that we are wishing to have an external client, let's say, connect mobile phones to the silos directly. I'm just saying that the front end could be something else, not technology.
But so, Gutenberg, don't you think we need to make that happen? We need a cross-platform wire protocol. That's kind of what Jason, I think, is saying. Like, for example, today we have binary protocol. We have fixed structure at the beginning of sizes of headers and the body of the message, so we can have the same size preamble, and then say, just for simplicity, both header and the body are base64 strings that are JSON encoded. So any client in the Java or Node.js, I presume, can easily format messages in that wire format and send them to the socket.
Uh-huh. Yeah, actually, go ahead.
Go ahead. Sorry.
Actually, like someone else said here, Alex said before, if we split the protocols between the message silo to silos will conform to the current protocol, and we make something else to connect to the client, we can make what Jason said to create a formal protocol for those kind of clients. But like they said, we have to split, which is silo to silo from which is client to silo.
Yeah, my son says we're in agreement on that. I don't think anybody objects to that.
And then so there's two options. Just look here. Either we standardize on Orleans' protocol, like the way you just described, Sergey, like, so there's a very clear preamble, and then there's like a whatever JSON thing. So, but basically, it's standardizing on Orleans' protocol. That's one approach.
Mm-hmm.
Or you actually allow replacement of the whole messaging stack.
Whoa, that's a lot of work.
No. Conceptually, you just put like another layer, clearly separate the messaging stack from the rest. It's not, and then you should bring someone else's RPC, right? So you bring whatever gRPC or thrift RPC. It can actually be easier, right? In some way. I'm not saying which one is better, but it's not inconceivable. Why is it much harder than percent?
I'm of the opinion that replacing the serializer and buffering would probably, the serialization and the buffering libraries or portions of the code would be far less difficult than replacing the entire messaging layer. Mainly because our messaging requires a lot of our lower level libraries right now, or lower level networking, use very specific things from the messaging layer. Not impossible. It's just it would be more work, and we get most of the advantage, I think, that we're looking for out of just replacing the serialization. Having said that, when we're talking about we want to use one protocol for silo to silo and another protocol from client to silo. I don't think it's necessarily that simple, because a lot of what the clients do when they communicate with silos is their messages are forwarded, right? And in forwarding them, you would want to maintain the format of the send. You wouldn't want to reformat. You wouldn't want to deserialize a message and then reserialize it in the internal silo-to-silo format every time you do that. You'd want to be able to just take a message and forward it to silo. No, hey, this message is in this serialization format. So you'd need some kind of basically tunneling frame on top of your messages saying this is a message from a client. And then when it goes to deserialize, the silos can deserialize using their internal silo-to-silo format, or they can use the client-to-silo format, so they don't have to reformat that. So my point is there's a lot more complexities to this than just changing the protocols without introducing performance issues.
I think it's a very good point because conceptually things are very easy. I receive message, transport, but a lot of the optimization is done for performance forwarding, where we don't touch the body. It's just the byte array, which we try even not to copy if we're going to forward it to another machine. But still, it's something to explore. Just time check. So we started about an hour ago. Are there any other questions that we haven't touched on? Because we can continue to chew on the same sort of questions, but I'm afraid if we missed something that people didn't have a chance to bring up.
Well, I mean, as far as going forward, I would prefer. I think it would be a more natural course to take the library we have now and clean it up and modularize it with some of the layers we discussed, like the serialization layer, the I/O layer, the messaging layer. Build some tighten those things up and build some abstraction layers in there, and then as consumers need various capabilities that are different from what we support, if we have this a little bit more layered, it will be easier for them to finish up that work by making it actual. Once it's been isolated, it can be replaced with people with specific needs, and then let the people with very specific needs replace those layers. I think as far as the first thing is getting it a little more organized and a little more layered so that we can. So somebody going in there actually has a chance of doing that. Because if somebody came into the library right now and said, "Hey, I want to replace X," it's like, no, it's not. It's not going to happen easily. It's not going to be fun to do. Not without a refactor of our existing code.
I just realized my chat window wasn't auto-scrolling, so I missed a bunch of messages. So Richard was talking about the library for handshaking. I think Julian asked us like AMQP would be a good candidate. ZeroMQ is also mentioned.
So Jason, I totally agree with what you just said, your last statement. I think this is the way to go.
Yeah, and to augment a little bit what Jason said about the messaging layer, making that a supple layer, or at least something that we can replace with something else, I agree that the return of investment might not be as high because it's a very complex thing, but at the same time, it's extremely hard to replace it with something that would give us the right semantics, whereas the networking layer, yeah, typically it's sending bytes, receiving bytes. Like nothing in our links or the usage of our links will change from that. With the messaging, it can be trickier to get similar or like leaking abstractions from that layer, or leaking implementations from that abstraction layer. I mean.
Okay, so should we wrap up? Anybody had any issues with Link versus Google Hangout? We'll take a look at the recording. We good?
Would that like the recording? Let's say if we do the meetups this way, but like and then we would post it on YouTube or what?
Yeah, so that's exactly what I want to try. So I started recording in the beginning, so I'll stop it in a few seconds and we'll see what comes out at replay. And it seems like this is easier to connect because you don't have to have this limited number of these people can talk and the rest they can just listen, and it's like 5 or 10 second delay. But let's see,
Yeah,
we can discuss the meetup issue. Links contribute.
Okay.
Sorry, Gutenberg, you were saying something?
No, it's just related to Link. We can talk about it later.
Okay, so then thanks to everybody who joined us in discussion. So I'm stopping recording and we'll try to post the recording later.
Okay.
Yeah, and I apologize for not necessarily following the conversation on text as well as I should. If there was anything that you guys wanted to ask that I didn't address, feel free to go on the issue on GitHub and just follow up on there with anything that I didn't that I might have missed. We always enjoy these conversations, even online. Thanks, guys.
Thank you, guys. See you later. Bye-bye.
Thanks all. Bye-bye.